this is an implicit differentiation problem. I want to find dy dx. So I'm just going to derive all the different pieces with respect to x, and I need to be really careful about all of my quotient and product and, well, not quotient, but my product and my chain rules. So I'm going to actually underline each of these in different colors and then work through their derivatives in a color-coded fashion. So I'm going to actually go ahead and rewrite everything, x cubed plus, and then I'm going to write y cubed like this so we can see the chain rule better, and then equals 6xy. So I need to do the derivative of x cubed. I'm doing it with respect to x, so I know that this is 3x squared plus, now we'll go to red. So you should see that I get my chain rule part, the derivative of the innards is y prime, and that is dy dx, right? Derivative of y with respect to x, times I get 3y squared for the power rule on that outer function, equal to, now I've got a, the way I like to see this is that this is my first function and this is my second function. That way I deal with my coefficients right. So the derivative of the first, 6x, is 6, and then I multiply it by the second, which is y. And then the derivative, and then I do plus. Derivative of the second is y prime, and then I get times 6x. So I'm going to rewrite a little bit of this. This gives me 3x squared plus 3y squared y prime equals 6y plus 6x y prime. So I want you to notice that everything's divisible by 3. You could do this step now or you could do it later, but I look at this and I say, all right, I'm going to divide everything by 3. So divide all the terms by 3. You should see that I get x squared plus y squared y prime equals, I get a 2y out of that, and then plus a 2xy prime. I'm just going to kind of scroll down. I want to solve for y prime, so I'm going to group things on different sides. So these are my y prime terms. These are my no y prime terms. So I'm going to take the y prime terms and go y prime. I'll go y squared y prime. Then I get minus 2xy prime. So that's this term subtracted over onto that side. This guy's got to move over there. I'll write the one that's already there first, so I get 2y, and I get minus x squared. So now I am going to, massive color coding, I'm going to pull these the y prime out, y prime times what's left in there, y squared minus 2x, and then that's equal to 2y minus x squared. And now I just have to divide by that bracket. So I'm going to divide by this and divide by that on this side. So I'm not going to rewrite that in there, but so that it cancels out. So what I get is that my y prime equals 2y minus x squared over, doesn't look like a squared, y minus x squared over, what's in that bracket? I get y squared minus 2x. Now, some of you may say, wait, I got this thing. Is that the same? Well, yeah, they're the same, but you didn't divide by that 3. Would it lose half a point? Maybe it lose half a point. Would it give you trouble on the actual AP? Well, it depends on how they ask the question. If you're on an FRQ, then this will give you this is fine. But sometimes they'll actually give you this and ask you to show them, kind of like in what number 5A on the no calculator section. Ask you to show them how you get to that. So anyway, that's the answer. That's what I'm looking for. You would get most of the credit, hopefully, if you gave me that.